Alright, we're back with Physics 212 practice exam number 2. This is problem number 9. So problem number 9 states a 4 kilogram mass attached to the end of a string swings in a vertical circle of a radius 2 meters. So on the paper it was nice enough to draw a circle and give us the radius, which is 2 meters. Pretty sloppy handwriting on my part. When the string makes an angle of 35 degrees with the vertical as shown, so if this is the center of the circle and this is the radius, and then it draws that we're at 35 degrees, but we're still on the same arc, we're still on the same circular arc, but now our mass is right here. And it tells us that the speed of the mass is 5 meters per second. So we're going to go ahead and assume that's velocity, tangential at this instant, alright? So it's a 4 kg mass, so m equals 4 kg. So let's go ahead and draw our free body. So regardless of what direction we're being pulled, mg always points to the center of the earth. However, in this case, tension can only be applied along the length of rope. So in other words, ropes can't exert, for example, shear forces. They can only exert tension. They can't even exert compression. So the tension force has to be pointed in the same direction as the rope. And therefore, the angle of the tension from the vertical will be 35 degrees. And likewise, the angle from mg to the tension line will be 35 degrees as well. Alright, so this is our free body diagram. And of course there's going to be some acceleration centripetal, right? And the acceleration centripetal is going to be orthogonal to the tangential velocity. And we know that AC is equal to v squared over r. This seems to be coming up a lot in these last couple problems. So let's go ahead and do our free body. If we wanted to sum, and actually let's pick our axes. I'm going to go ahead and pick, this is a little bit weird, but it seemed to work out better for me. I'm going to go ahead and pick my x-axis orthogonal to the tension, and my y-axis in the same direction as the tension. So when I sum my forces in the y direction, and guess what? It's equal to 0, right? Because at this point, or I'm sorry, it's not equal to 0, it's equal to acceleration centripetal. So the sum of forces in the y equals mac, and then we'll write our forces. Well, we've got positive T, positive tension, minus, and then we have to project mg onto our tension line here, and of course that's going to be adjacent with the angle 35, so that's going to be mg cosine 35 degrees equals mac. Alright, so that is getting us in the right direction. What the question is asking for, it says at this instant, what is the magnitude of the force the string exerts on the mass? So we're looking for the magnitude of the tension. So we really want to solve for tension. So let's get tension all on its own. Subtract mg cosine 35 over there. Alright, now let's see what we have. Well, we know AC is equal to v squared over r. So let's go ahead and do that substitution. We know mass. Okay, so we know mass. We know mass, we know radius, we know v, we know mass, we know gravity, we know cosine 35. So the only unknown that we have at this moment is tension, so we can go ahead and solve for that. Let me make some room here. Alright, so we'll plug in our values. Tension equals mass, which is 4 kgs, times v squared, which is 25, 5 squared over r, which is, let's see here, 2 meters. Plus mass is 4 kg, gravity is 9.8 meters per second squared, And then cosine 35 is roughly 0.819. Alright, so now we'll just work everything out. This term ends up being 50. This term ends up being 32.1 approximately. And so therefore tension is approximately 82.1 newtons. And remember, this is not a vector anymore. This is just the magnitude, because we have nothing intrinsically telling us the directionality of tension. And so what we set out to solve for was the magnitude of tension, and that's exactly what we did solve for. So the magnitude of tension is 82.1 newtons approximately. So I hope this was useful, and I'll see you next video.